Dawn breaks slowly over the central Pacific, not with silence, but with the steady metallic pulse of engines idling on open water. A thin mist rises from the ocean's surface, turning the horizon into a blur of silver and pale gold. On this morning in 1944, no one aboard the strange vessel anchored here could forget where they were, nor what waited just over the curve of the sea. The ship looks nothing like a warship. No gun turrets. No tower of steel bristling with antennas. Instead, cranes stand like skeletal arms over a deck crowded with machine tools, welding stations, spare engines, and crates of aircraft parts secured with thick rope. It is not a destroyer, not a cruiser, not even a carrier. It is a floating factory. A place where men repair machines built for the sky, while drifting in the middle of an unforgiving ocean. Below deck, the heart of the vessel hums. Lathes spin. Sparks dance from acetylene torches. The scent of hot oil and diesel mixes with salt air. Technicians in grease-stained overalls work in synchronized rhythm. These are not sailors in the traditional sense. They are machinists, sheet metal specialists, instrument technicians, the quiet core of an idea so unconventional that, 2 years earlier, it had seemed impossible. Machinery on the water. Aviation workshops on a ship. Factories that move as fast as the front line. The Pacific War is not static. Fronts shift by hundreds of miles in weeks. Bases appear on islands barely known to American maps. What had worked in 1942, fixed airfields, rear area depots, long transportation chains, collapses under the speed of the advance. By 1944, bombers press deep into Japanese-held territory. Missions stretch beyond safe recovery distance. Engines overheat. Turbos fail. Props vibrate themselves apart. Crews limp home, bringing aircraft so damaged they could never return to the air without immediate, expert repair. But the nearest major repair base might be 2,000 miles away. This is the crisis the United States faced, a crisis invisible to the public, but painfully real to every pilot who wondered whether his earthbound mechanics would still be thousands of miles behind. And so, in one of the most unusual acts of wartime engineering, the United States Army Air Forces and the U.S. Navy approved an experiment. Turn cargo ships into mobile aviation depots capable of repairing B-29s, B-24s, P-51s, and every machine in between, right at the edge of the battlefield. An idea code-named Ivory Soap. On this ship, one of 6 converted Liberty vessels, a damaged bomber can land on a nearby island airstrip, its engines still ticking with heat. Within hours, its broken parts are ferried by boat to this floating workshop, where machinists fabricate replacement components from raw stock. Compressors whine. Rivet guns hammer. The ship becomes a heartbeat of production in a place where nothing resembling industry should exist. And then, before anyone ashore can fully grasp what happened, the bomber returns to the sky. Reborn. The war in the Pacific has shifted. And the Japanese have no idea why American aircraft seem to repair themselves overnight. What the enemy cannot see, what even many Americans never learned, is that this transformation began here, aboard these quiet vessels, far from any city, driven by ingenuity, necessity, and the relentless pace of a global war. The floating factories are awake. The Pacific will never be the same. The idea of a floating aircraft factory did not emerge from a conference room in Washington. It was born from a crisis, quiet, logistical, and dangerously underestimated, unfolding across the Pacific in late 1943. American strategy depended on long-range aviation. The Pacific theater was unimaginably vast. Thousands of miles of open water, scattered islands, coral runways, jungles, and weather patterns capable of grounding entire fleets. Every advance pushed the front line farther from the industrial backbone of the United States, and deeper into areas where infrastructure barely existed. At the center of this challenge stood the B-29 Superfortress program, a machine powerful enough to reach mainland Japan, but still experimental, delicate, and plagued by early mechanical failures. Its engines, the Wright R-3350 duplex cyclone, generated enormous heat. Turbo superchargers failed. Cylinders cracked. Carburetors misfed. Even the smallest malfunction could prevent an aircraft from taking off again for weeks. And the nearest major service depot? Often more than 3,000 miles behind the advancing line. In the winter of 1943, General Henry Hap Arnold received a series of alarming field reports. B-29s were piling up on forward bases, waiting for parts, tools, and specialists who simply could not arrive in time. Squadrons risked grounding entire missions because a single component, a magneto, a control surface hinge, a turbo assembly, was missing. The Pacific wasn't just an ocean. It was a logistical abyss. Meanwhile, Lieutenant General George C. Kenney, commander of Allied air forces in the Southwest Pacific, pushed the limits of air operations from New Guinea to the Philippines. His units needed mobility and self-sufficiency. Every day lost to repair delays cost pressure on the enemy. Kenney understood something fundamental. In the Pacific, mobility is combat power, and mobility depends on maintenance. But how do you move an entire industrial workshop across an ocean? The answer began unexpectedly with a man rarely mentioned in wartime documentaries. Lieutenant Colonel Kenneth B. Wolfe, a B-29 project officer with a mind for engineering and unconventional solutions. Wolfe saw the problem not as a lack of factories, but as a lack of delivery. Factories existed in California and Kansas, but the battlefield was moving too fast for them. Wolfe asked a question no one else dared. Could a factory travel with the fleet? He turned to the U.S. Maritime Commission and the Army Service Forces, proposing something audacious: convert standard cargo vessels, Liberty ships and smaller auxiliary transports, into floating depots equipped with lathes, milling machines, sheet metal shops, engine rebuild centers, and dedicated aviation part storage. It sounded impractical. It sounded expensive. And yet, every day, aircraft were being lost not to enemy fire, but to mechanical delays that could have been prevented. The feasibility study did not take long. Cargo ships had space. They had power. They had stability. And with modification, they could host every machine tool necessary to fabricate aircraft parts from raw aluminum and steel. The plan received a code name almost comically unrelated to war: Ivory Soap. No one knows precisely why. Some records suggest it referenced the idea of cleaning logistical delays. Others hint it was chosen simply because it sounded harmless. In a war filled with codenames like Iceberg, Torch, or Detachment, Ivory Soap appeared disarmingly domestic, and that was exactly the point. Within months, 6 Liberty ships and dozens of smaller vessels were selected for conversion. But the ships alone were not enough. They needed a crew of a new type of soldier. Men who were not sailors, not mechanics, not engineers, but all three at once. And so began one of the most unusual training programs of the entire conflict, a story that would define the next chapter of the floating factories. They called it a training program, but for the men chosen for Ivory Soap, it felt more like being drafted into a new, unknown branch of the military, one that did not yet exist. In early 1944, the Army Air Forces began selecting personnel from aviation depots across the United States. Machinists, welders, engine specialists, sheet metal workers, radio technicians, propeller experts, hydraulic mechanics, and instrument repairmen. Most of these men had spent their service careers in hangars, not in combat zones. Their world was concrete floors, fluorescent lights, and the stable hum of machinery. Now they were told they would be going to war on ships. Many had never set foot on a vessel larger than a ferry. The training site chosen for this new experiment was the University of Montana in Bozeman, a location far from any ocean, almost absurdly so. But the idea was deliberate: isolate the recruits, teach them naval fundamentals, and transform them into hybrid soldiers capable of surviving at sea while performing aviation-level repair work. A typical day began before sunrise. Not with calisthenics or rifle drills, but with shipboard firefighting, emergency repairs, damage control, and naval communications. They practiced abandoning ship in frigid mountain reservoirs to simulate Pacific conditions. They learned how to navigate by compass and stars. They absorbed maritime weather patterns and basic seamanship. And after the naval portion ended, the second life of the training day began. Workshops filled with machines hummed into motion: milling machines, precision grinders, lathes, drill presses, sheet metal brakes, and welding rigs. Instructors demanded perfection. A single component miscalculated by 1 degree could doom an aircraft in combat. "You're not here to fix planes," a senior instructor told them. "You're here to keep men alive." Slowly, the recruits understood the responsibility. They were preparing to repair B-24s, B-25s, P-38s, and especially B-29s in some of the harshest and most isolated conditions of the war. The psychological transition was harder than the physical one. Many realized that once deployed, they would no longer work in the safety of a stateside hangar. They would fabricate parts under fire, in monsoon rain, on a ship rolling in heavy seas. If they made a mistake, a bomber crew could vanish over the Pacific the very next day. Still, the program demanded not just technical skill, but adaptability, and that meant exposure to the real environment they would soon face. So the Army brought in Navy instructors to teach them how to secure machinery during rough seas, how to brace a lathe that threatened to vibrate off its foundation, how to weld while the deck pitched unexpectedly, and how to protect precision tools from salt corrosion. By the end of the course, they were no longer simple technicians. They were aviation repair units, floating, a new classification created specifically for Ivory Soap. Then came the moment everyone had waited for: seeing the ships themselves. When the first contingent of trained men arrived at the docks in San Francisco and Mobile, they froze. The Liberty ships being converted for Ivory Soap looked nothing like the transports they had imagined. Massive cranes had replaced cargo booms. The holds had been gutted and rebuilt into multi-level workshops. Entire sections of deck were reinforced to support heavy machine tools. Ventilation systems had been rerouted. Storage bays held thousands of aircraft parts, meticulously catalogued. One machinist later wrote, "It was as if someone had taken a depot from Kansas and welded it onto the deck of a ship." The vessels were not beautiful. They were not elegant. But they were functional, brutally functional, and designed for a mission no military had attempted before. Each man stepped aboard knowing that the next time he touched solid land, it might be months later, on a frontline island carved from coral and surrounded by danger. The floating factories were nearly ready. The men who would operate them, forged in classrooms, workshops, and cold mountain lakes, prepared to enter the Pacific not as sailors or mechanics, but as a new breed entirely. A breed created for a war that demanded movement, speed, and ingenuity at a scale the world had never seen. When the Navy shipyards received the order to convert 6 Liberty ships into mobile aviation depots, the reaction was a mix of curiosity and disbelief. Liberty ships were the workhorses of American logistics, simple, standardized, and built for cargo, not precision engineering. They were floating boxes of steel with engines, never intended to host the delicate machinery required for aircraft fabrication. Yet the deadline was uncompromising. The floating factories had to be ready for deployment in 1944. The first step was brutal in its simplicity: strip the ships down to their bones. Cargo holds were gutted. Deck plating was removed. Bulkheads were cut open to allow new layouts. The internal structure of each vessel was redesigned to support heavy equipment that would normally sit in a stable building on land. The largest of the vessels, the Liberty-class ships, were assigned to become aircraft repair units, floating ARUs. Their design would include machine shops with full-size lathes and milling machines, sheet metal fabrication bays, welding and casting stations, specialized engine repair rooms, precision instrument workshops, electrical and radio repair labs, propeller balancing rigs, storage for more than 22,000 cataloged aircraft parts. This wasn't improvisation. It was industrial architecture at sea. Engineers faced an immediate challenge. Machine tools operate with razor-thin tolerances. A lathe cannot misalign because the deck rolls under it. A milling machine cannot lose calibration because of vibration from the ship's engines. Every tool had to be mounted with reinforced bases, shock-absorbing brackets, and anti-vibration mounts custom-built for maritime use. Some equipment weighed several tons. Installing it required cranes and careful balancing calculations. If placed incorrectly, the ship could list dangerously. Then came the second challenge: power. Machine tools require steady electrical current, not the inconsistent output typical of wartime ships. So engineers installed new generators, power converters, and distribution panels designed to feed workshops with uninterrupted current. Ventilation was another problem. Welding fumes trapped below deck could become deadly. Grinding aluminum or magnesium could create explosive dust concentrations. New airflow systems were built, venting through armored ducts that snaked upward to the deck like metallic arteries. And then there was storage. Aircraft parts come in every size and shape imaginable, from small gyros to full B-29 wing sections. Storage bays were redesigned with modular racks, climate-protected containers, and rapid access stations. Every part needed to be accessible in seconds during combat operations. On the decks above, cranes were installed to lift engines, wing segments, and damaged components directly from landing craft alongside the ship. Each crane could swing heavy assemblies across the deck with precision, even in rough seas. By the time the conversions neared completion, the ships no longer resembled cargo vessels at all. They were floating industrial complexes. But the transformation wasn't limited to Liberty ships. 30 smaller vessels, FS ships, freight and supply, were converted into aviation repair tenders capable of servicing fighters and medium bombers. These smaller ships would accompany amphibious landings and operate closer to the front line. The differences were striking. Liberty ARUs, large-scale facilities for heavy airframes and engines. FS tenders, rapid response units, able to repair fighters within hours of landing on captured islands. Together, they formed a layered support network unlike anything else in the war. Yet the most impressive aspect of the conversion was not its complexity, but its purpose. The Pacific was filled with coral islands too small or too undeveloped to host proper repair depots. Airfields there could receive aircraft, but they could not rehabilitate them. Ivory Soap solved that problem by bringing the depot to the airfield. When the last inspection teams walked the decks of the newly transformed vessels, they understood something remarkable. These ships held the capability of a full aviation depot, but they could move hundreds of miles in a single day. A machinist later recalled, "We could turn a damaged B-29 into a mission-ready aircraft while floating in the middle of nowhere." That was the power of it. The floating factories were no longer an idea. They were real, fueled, and ready. Ahead of them waited the vastness of the Pacific, and the first test of whether this unprecedented engineering gamble would actually work. The departure of the Ivory Soap vessels from the American West Coast did not look like the beginning of a major wartime innovation. There were no ceremonies, no speeches, and no fanfare. The ships slid out of their berths in San Francisco, Oakland, and Mobile under gray skies, escorted only by tugs and the cries of seagulls circling overhead. But to the men aboard, the moment felt monumental. For the first time, these floating factories were not diagrams, plans, or concepts. They were living systems, engines humming, generators vibrating, workshops stocked with tools polished to a mirror sheen. Everything was clean, ordered, and ready. And then, they met the Pacific. The first days at sea were an initiation. The Liberty ships, designed for cargo, rode the waves with the grace of a brick. Their flat hulls slammed into swells, sending shudders through the steel frame. For machinists accustomed to stable hangars, the motion was disorienting. Men staggered between bulkheads. Toolboxes rattled. A few machines required immediate rebracing after unexpected vibrations. Worse than seasickness was the fear that the ship's constant roll would disrupt precision work. Some technicians wondered, if we can't keep a wrench steady, how will we ever machine a turbine shaft to spec? But the crew adapted quickly. They secured tools with additional clamps. They tightened mounts. They learned to brace their bodies with each swell, aligning their work with the motion of the ship. What had seemed impossible on day 1 became instinct by day 5. Then came the first aircraft emergency, a test sooner than anyone expected. A B-29 B-24 from a forward reconnaissance unit reported trouble mid-flight during a ferry mission toward the Marshall Islands. One engine began overheating. Oil pressure dropped. The pilot nursed it across the last 100 miles, landing on a rough coral strip barely long enough to stop the bomber's heavy frame. Forward units radioed ahead. "We have a crippled bird. Need repair capability immediately." The nearest fixed depot was 12 days away. But one of the Ivory Soap ARU ships, the USAT Major General Herbert A. Darg, was only 60 miles off course. Within hours, the floating factory diverted from its transit formation and altered its heading toward the airstrip. The crew felt a collective shift. Their mission was no longer theoretical. As they approached the island, technicians gathered at the railings. The sight was harsh and surreal, a strip of crushed coral carved into jungle, dotted with tents, fuel drums, and a single B-24 parked with its cowling open like a wounded animal. Ground crews waved them in, exhausted and covered in dust. The repair team boarded landing craft and crossed ashore with toolkits strapped to their chests. They moved fast, not with the pace of civilians, but with the urgency of men who knew every minute lost meant more strain on the air war. It took less than 20 minutes for the lead machinist to diagnose the problem. A cracked engine mount and a failing turbocharger assembly, both requiring fabrication. In a traditional scenario, the aircraft would be grounded indefinitely. But this was different. Now the repair team had something no frontline unit had ever possessed, a full machine shop floating offshore. Parts were ferried back to the ship. Inside the workshop, lathes spun up. Sparks flew. The smell of hot metal filled the air. The rhythmic clatter of tools echoed through the hull as metalworkers crafted replacement components from raw stock, pieces that normally would have come from a stateside depot thousands of miles away. By nightfall, the new mount and turbo components were ready. By dawn, the crew installed them on the bomber. By noon, the B-24 rose from the coral airstrip and rejoined operations. A process that should have required weeks had taken less than 20 hours. For the men of Ivory Soap, it was a revelation. Their mission worked. Not on paper, not in theory, but in the humid, unpredictable, unforgiving frontline reality of the Pacific. The ship's commanding officer wrote in his log, "The concept is validated. The factory moves with the war." And deep in the Pacific, news of the strange ship that repaired airplanes began to spread through aircrews like rumor and legend. By mid-1944, the Pacific War had changed pace. What had once been a slow, grinding advance became a sudden acceleration, driven by the capture of the Mariana Islands, Saipan, Tinian, and Guam. From these islands, the United States could finally launch long-range bombing raids against Japan using B-29 Superfortresses. But the moment the first B-29s arrived on the newly carved airfields, one truth became obvious. The fleet was not ready for the mechanical demands that were coming. The Marianas were remote, harsh, and under constant threat. Airstrips were carved from coral that chewed through tires. Heat warped metal. Sudden tropical storms grounded aircraft and soaked equipment. And above all, the B-29, still a young and temperamental machine, pushed its engines to limits unseen in earlier bombers. Failures became common. Overheated R-3350 engines. Turbocharger seizures. Cracked exhaust manifolds. Warped cylinder baffles. Electrical shorts from humidity. Failing prop governors. Vibration-induced stress fractures. Each problem required specialized tools and parts. Normally, a stateside depot would handle such work. But the nearest one was effectively on another world. And under this pressure, Ivory Soap came into its own. The arrival of the floating factories. When the first ARU ships anchored off Saipan and Tinian, the sight stunned the exhausted ground crews. From the coral beaches, the vessels looked like small industrial cities, cranes raised like mechanical spires, ventilation ducts running across their decks, cargo hatches open to reveal glowing machine shops below. The island crews were operating on minimal sleep, overwhelmed by aircraft that could barely complete a mission without suffering new damage. The arrival of Ivory Soap was not just welcome, it was transformative. Landing craft began ferrying damaged components from shore to ship in a constant cycle. Cracked B-29 intercoolers, seized prop hubs, bent landing gear trunnions, blown ring and pinion assemblies, warped control surface hinges. Entire nose wheel forks shattered on coral. The ARU machinists moved with practiced urgency. Inside the Liberty ships, the workshops roared. Sparks cascaded from welding masks. Drill presses hammered through aluminum. The smell of cutting fluid, hot steel, and damp sea air filled the decks. On some days, the ships fabricated more parts than an entire inland depot might produce. Working under fire. The Marianas were not safe. Japanese aircraft still launched night raids, rare but terrifying. Anti-aircraft guns on the ships barked into the darkness as crews worked below deck, bracing themselves against the concussive thump of their own guns. One machinist later wrote, "You learned to keep turning the lathe even when the deck shook. If you stopped every time the guns fired, nothing would ever get done." The floating factories repaired. Shot-up turrets. Blown-out hydraulic lines. Scorched wiring looms. Engine mounts warped by overheating. Tail assemblies damaged by flak. Many of these parts were kept in short supply, and Ivory Soap began manufacturing them from raw material stock, effectively becoming mobile production nodes in a theater with almost no infrastructure. Increasing scale and rhythm. As operations intensified, the workflow became almost industrial. Aircraft lands damaged. Ground crew removes failed parts. Parts ferried to ARU ship. Ship fabricates replacements. Repaired parts returned to airfield. Bomber re-enters the fight in 24 to 48 hours. What once required weeks now took days. Sometimes hours. The pace was relentless. But the effect was unmistakable. A B-29 commander wrote in his mission diary, "We no longer feared mechanical failure the way we used to. The ships were our lifeline. They kept the air war alive." A strategic shift. The Japanese could not fully grasp what was happening. Intelligence reports noted that damaged American aircraft were returning to service far too quickly, as if the islands themselves had become factories. But it wasn't the islands. It was the ships offshore, turning the Pacific into a mobile industrial zone. The Marianas campaign proved something beyond doubt. Ivory Soap wasn't a support program. It was a force multiplier. And now, every major operation in the Pacific depended on it. The floating factories had passed their trial by fire. Ahead waited the final, most demanding stage of the war, operations against the Japanese home islands. By late 1944, Tinian had become the beating heart of America's strategic air campaign, a place where entire squadrons of B-29 Superfortresses launched into the sky every single day. The island's runways, 6 miles of white coral carved with mathematical precision, were among the busiest in the world. From here, the bombers could reach Tokyo, Nagoya, Osaka, and Yokohama. But the pace was brutal. Every night, dozens of B-29s returned wounded. Some limped in on 3 engines. Some arrived trailing smoke. Some touched down with landing gear half-failed, scraping steel against coral in a shower of sparks. And waiting offshore, silhouetted against the horizon, were the floating factories of Ivory Soap, their hulls lit from within, workshops glowing like industrial lanterns on the Pacific. The demands placed on the ships reached a level no one had anticipated. The engine crisis. The R-3350 engine remained the Achilles heel of the B-29. Its 18 cylinders produced immense heat at high altitude. Turbochargers strained. Failures became a nightly ritual. Warped cylinder heads. Cracked exhaust flanges. Broken valve trains. Oil leaks that soaked entire nacelles. Supercharger blowouts that left bombers crawling home at low altitude. Normally, these failures required depot-level intervention. But depot-level facilities didn't exist here. Ivory Soap became the depot. Engine rooms aboard the Liberty ARUs ran at full throttle. Men worked shirtless in the heat radiating from disassembled engines, their hands blackened with oil and graphite. They rebushed piston rods, resurfaced valve seats, honed cylinders by lamplight, and machined custom gaskets on the fly. Every hour saved meant another bomber back in the sky. A single ARU ship could service 22 engines per week, an impossible number anywhere else in the Pacific. Reparos, impossibles. Some of the most extraordinary repairs were ones that no manual would ever sanction. One B-29 returned with a severely damaged wing spar, its internal structure twisted by flak. A ground crew chief declared the aircraft a total loss. But a machinist aboard the Major General Herbert A. Darg disagreed. Working from sketches and measurements taken on the flight line, he and his team fabricated a reinforced spar component from heat-treated aluminum billet. The part took 8 hours of continuous milling, followed by precise drilling, deburring, and stress testing. The replacement spar fit perfectly on the first attempt. The aircraft flew again 3 days later. Another bomber landed with both main landing gear struts blown out after a coral field emergency landing. The crew expected to be transferred to another airframe. Instead, the ARU ship's welding team built new chromoly steel reinforcement sleeves and refitted the shattered trunnions. A pilot later recalled, "They handed us back a plane we thought was dead. We named her Factory Girl, after the men on the ship." Keeping the Superfortress in the fight. As missions extended deeper into Japanese territory, the wear on airframes multiplied. Pressure differentials warped fuselage skins. Nose wheel assemblies cracked. Control cables stretched to unsafe lengths. The floating factories adjusted in real time. They built entire instrument panels from scratch. They fabricated oxygen system fittings that had no spare equivalents. They machined bomb bay door actuator components by night for next-day missions. They rebuilt tail gunner fire control units damaged by high-altitude icing. What emerged was a new kind of rhythm. Bomber returns, diagnosis on the field, parts ferried to ship, fabrication, return to field, aircraft flies again. The cycle became so efficient that some B-29 squadrons reported 0 mission cancellations due to mechanical failures for weeks at a time. A statistic unheard of in any other theater. The human weight of the work. For the machinists, the pressure was constant. They didn't fly the missions. They didn't drop bombs. But they felt responsible for every crew that climbed into a repaired aircraft. A lathe operator wrote in his diary, "You hear them take off. You wonder if something you touched is up there with them, trying to hold together in the cold." The war pressed harder every day. But the ships endured, rolling in the swell, lit from within, engines humming, machines clattering through the night. On Tinian, the B-29s rose like thunder. Offshore, the floating factories kept that thunder alive. By early 1945, the campaign against Japan had entered a new phase, one defined by distance, endurance, and the unrelenting strain placed on every aircraft in the Pacific. The capture of Iwo Jima was still underway when the floating factories received a new directive. Support emergency operations for crippled B-29s attempting to reach the Marianas. To pilots, Iwo Jima was more than a volcanic rock. It was a lifeline. Many bombers returning from raids over Tokyo arrived with engines burning oil, fuel tanks punctured by fighters, turbos damaged by overheating, oxygen systems iced over, navigation instruments fried by electrical surges, landing gear partially inoperable. Without Iwo Jima, thousands of airmen would have been lost at sea. With it, they could attempt emergency landings. But the island itself had no infrastructure to repair superfortresses. That responsibility fell to Ivory Soap. The first wave of emergency landings. As Marines fought their way up Mount Suribachi, the first B-29s limped toward the island. Some touched down too fast, skidding across the black volcanic ash. Others lost brakes and smashed through sandbag barriers. One bomber landed with its right wing on fire, collapsing into the soft terrain as its landing gear buckled. And behind the chaos, offshore, the floating factories turned toward Iwo Jima at full speed. Landing craft shuttled constantly between the island and the ships, at times moving through smoke drifting from the still active battlefield. The machinists could hear artillery in the distance as they unloaded broken engines, twisted landing gear arms, mangled props, and scorched exhaust systems. 4 days, the workshops ran without pause. A repair supervisor aboard the USAT Major General Robert Olds later described it. "We were repairing aircraft while the battle was still being fought. The smell of cordite and machine oil mixed in the air. Operations under fire. Iwo Jima was not yet secure. Japanese artillery still hit the airstrip sporadically. Aircraft attempting emergency landings scattered debris across the runway. Ground crews worked under threat, dragging damaged bombers off the strip so others could land behind them. For Ivory Soap, this meant chaos and opportunity. One B-29 landed with its entire nose wheel assembly sheared off. The bomber sat nose down, resting on its forward bulkhead. Normally, this would be the end of the airframe's life. Instead, technicians aboard the ARU ship fabricated a new fork assembly from heat-treated chromoly steel, strengthened beyond original specifications. They machined it in 11 hours and ferried it to the island in the middle of the night. By morning, the bomber stood upright again. Another aircraft arrived with 3 of 4 engines non-functional, electrical fires still smoldering inside the nacelles. Shipboard electricians reconstructed damaged wiring harnesses while machinists rebuilt impeller housings and turbochargers from raw castings. The bomber flew again 4 days later. The strain on the floating factories. The workload was unlike anything the machinists had ever imagined. Workshops ran 24 hours a day. Men slept beside running machines during brief lulls. Vibration from constant seas made precision work exhausting. Salt corrosion attacked tools faster than crews could maintain them. Heat from engines, welding, and Pacific humidity turned the workshops into furnaces. And yet the work continued. Every time crews thought the pace might slow, another wave of damaged B-29s appeared over the horizon, limping home after missions that pushed the aircraft to structural and mechanical limits. The floating factories absorbed it all. A ground crew chief on Iwo Jima wrote in his log, "I have never seen men work like this. They make our bombers whole again." A turning point, sustaining the Tokyo raids. As more B-29 survived because of Iwo Jima, mission planners realized something extraordinary. Ivory Soap was increasing bomber survivability by a measurable margin. Every B-29 saved by the island, and repaired by the ships, was another aircraft that could return to the skies for the next strike. Every repaired turbo, cylinder head, or prop governor meant fewer aborts, fewer ditchings, and more pressure on Japan's industrial centers. The floating factories were no longer simply maintaining the air war. They were enabling it. And now, with the next phase of the campaign beginning, the low-altitude incendiary raids that would devastate Tokyo, the importance of Ivory Soap rose to its highest level yet. Ahead lay the greatest mechanical strain ever placed on the B-29. And the floating factories would shoulder the burden. In March 1945, the air war over Japan changed in a single night. General Curtis LeMay ordered a radical shift in tactics, abandon high-altitude precision bombing and attack Japanese cities from low altitude, carrying loads of incendiaries rather than general-purpose bombs. It was a strategy designed to punch directly at the industrial and urban heart of Japan. But for the aircrews, and for the machines they flew, the change was catastrophic. The B-29 Superfortress had been engineered for the cold clarity of 30,000 feet. Now it would fly at 5,000 to 7,000 feet, where turbulence became violent. Drag increased dramatically. Engines ran hotter. Fuel consumption skyrocketed. Anti-aircraft fire became far more accurate. And above all, the weight of the incendiary load strained every component of the airframe. For the floating factories offshore, this meant only one thing. Everything was about to break. Operation Meeting House, the night that broke the fleet. On March 9 to 10, 279 B-29s took off from the Marianas in the dead of night. They flew low, carrying 1,665 tons of incendiaries. Tokyo burned like a furnace. But the victory came at a mechanical cost no one had foreseen. Many aircraft returned with scorched engine cowlings from flying through rising heat columns, propeller blades warped by thermal stress, tail surfaces peppered with debris and shrapnel, hydraulic systems cooked in the heat, bomb bay doors damaged by suction from firestorm updrafts, structural rivets loosened by turbulent air. The next morning, offshore, the floating factories looked like emergency wards. Landing craft brought in a flood of broken components, far more than the ships had been designed to handle at once. Crates overflowing with warped control surfaces, heat-warped turbo housings, and melted electrical connectors piled up along the decks. Yet the crews didn't panic. They organized. They adapted. And then they worked. Heat, the silent enemy. Low-altitude operations exposed the B-29 to temperatures the engineers had never anticipated. Engines came back so hot that crews could smell scorched insulation from the cockpit. One machinist aboard the USAT Major General William Bryden recalled receiving a set of turbocharger components still warm to the touch even hours after landing. To deal with the unprecedented thermal damage, ARU teams developed improvised procedures. Rapid quench baths to cool warped steel for measurement. Emergency heat treatment cycles on deck using makeshift furnaces. Controlled rebending of prop blades using calibrated hydraulic presses. High-strength steel inserts to reinforce weakened mounting points. These techniques were not in any manual. They were invented at sea, in the moment, by necessity. A bomber saved by a midnight rebuild. One of the most dramatic repairs occurred after a B-29 from the 504th Bomb Group returned barely usable. Flak had shredded its wing leading edge, the engine mounts were cracked, and the bomb bay doors were jammed half open. Ground crews declared the aircraft unfit to fly again. But the pilot, a man who had flown 22 missions, asked the ARU commander to try. The floating factory went to work. New wing segments were fabricated from raw aluminum sheets. Damaged ribs were drilled out and replaced. A fresh bomb bay actuator was machined in 7 hours. Both engine mounts were reinforced beyond factory spec. Wiring harnesses were rebuilt from scratch using tinned copper from ship stores. The aircraft flew again 3 days later. The pilot reportedly told his crew, "If the factory ship can keep her alive, we'll keep flying her." The pressure never stopped. As the incendiary raids continued, the damage multiplied. Fuselage skins blistered from heat. Control surfaces warped by violent air currents. Superchargers burned out. Exhaust stacks cracked. Oxygen regulators failed. Entire engine nacelles scorched black. Every mission sent back a new type of failure. And every failure forced Ivory Soap to expand what it could do. Soon, the ARUs were not just repairing parts, they were modifying them. Strengthening. Re-engineering. Improving weak points revealed by combat. The floating factories had become something more than depots. They were evolving the B-29 in real time. A new kind of superiority. Japanese defenders struggled to understand how American aircraft maintained such relentless consistency. They didn't know that offshore, under minimal escort, in steel workshops lit by bare bulbs and humming with machinery, thousands of micro-decisions were keeping the air war alive. The result was devastating for Japan. More aircraft survived. More aircraft returned. More aircraft flew the next night. The incendiary phase of the war became a mechanical marathon, and only because Ivory Soap existed did the United States sustain it. Ahead lay the final battles, and the floating factories were about to face the most decisive months of the war. By May 1945, the air campaign over Japan had reached an intensity unmatched in the entire Pacific War. Night after night, B-29s lifted from Tinian, Saipan, and Guam in waves so dense that ground crews described the sound as a single continuous thunder. The bombers flew low over coastal cities, dropping fire and steel onto a nation already stretched to its limits. But the pressure on the aircraft, and therefore on Ivory Soap, became nearly unsustainable. In this final phase of the war, the floating factories faced a new reality. There was no margin left. Every aircraft mattered. Every hour mattered. Every repair mattered. Mechanical failures no engineer had planned for. As temperatures rose with summer approaching, engine failures surged again. Fuel ran hotter. Lubricants thinned. Turbo systems overheated faster. Electrical components burned out under peak load. The R-3350 engines suffered incredible stresses. Thermal distortion of crankcases. Cracking of cylinder fins. Blown pistons under extreme manifold pressures. Bearings scoured by degraded oil. Spontaneous ignition in overheated carburetor housings. These were not routine failures. They were signs of a machine being pushed to the very edge of what metallurgy and physics could support. And yet, operations continued. The rhythm of overload. Every morning, the sea around Tinian and Saipan shimmered with movement. Landing craft carried damaged parts in an endless loop from airfields to ship. Crates piled high with scorched turbocharger housings. Entire propeller assemblies soaked in seawater from emergency recoveries. Sections of wing skin buckled from fighting crosswinds in low-altitude night raids. On board the floating factories, the atmosphere felt electric, charged with urgency, fatigue, and mechanical noise. Workshops ran at peak capacity. Grinders shrieked. Hydraulic presses slammed. Welders flashed like lightning in darkened bays. Crankcases were honed with precision micrometers. Sheet metal teams patched scorched fuselage panels until their hands shook. Some machinists worked 16-hour shifts. Others 20. A few nearly 24. A senior toolmaker aboard the USAT Major General Herbert A. Darg wrote, "We stopped counting hours. We only counted aircraft. Reparos que desafiavam a logica." The sheer variety of failures forced Ivory Soap to innovate on a near-daily basis. A B-29 returned from an Osaka mission with 2 feet of its left wing leading edge missing, torn away by debris sucked into the firestorm uprisings. ARU teams on the ship hand formed new skin panels from raw aluminum, shaping them by hammer, jig, and heat. Craftsmanship that bordered on artistry. The wing was rebuilt in less than 48 hours. Another aircraft landed with a bomb bay door bent inward by shockwaves, stuck half open. Without repair, the aircraft would be a deadly hazard on its next mission. The floating factory fabricated a new torque tube assembly overnight using cold-rolled steel stock, restoring the bomber to full operational readiness by morning. Yet another B-29 returned with its radar set fried beyond repair after a close burst of anti-aircraft fire. The ARU's electronics specialists rewired the unit from scratch, soldering every connection by hand, guided only by technical manuals and memory. The bomber flew again 3 days later. The emotional weight builds. Despite their stoic professionalism, the machinists and technicians felt the emotional weight of the moment. Many had spent months working far beyond exhaustion. Saltwater corroded tools faster than replacements could arrive. Sweat rolled constantly in the tropical heat. Fatigue gnawed at focus. Yet the war didn't stop. The mission tempo didn't slow. If anything, it intensified. One machinist recalled, "We'd hear the engines warming up on the runways at night. We knew which aircraft we had worked on. We knew which crews trusted us with their lives." It wasn't pride they felt. It was responsibility, heavy, constant, and unspoken. A war sustained by steel and ingenuity. By now, Ivory Soap had become a backbone of the entire Pacific air effort. Military planners openly acknowledged that the sustained bombing of Japan depended on the ARU ships. Without them, engine failures alone would have grounded half the fleet. But the most remarkable truth was this. The floating factories were not simply repairing the war effort. They were holding it together. And as the summer of 1945 approached its peak, the stresses on the B-29, and on the men who kept it airborne, were about to intensify one last time. Ahead lay the final missions, the most demanding, the most symbolic, and the ones history would remember forever. By August 1945, The Pacific War had narrowed to a final, brutally compressed timeline. Japan's defenses were faltering, its industries crumbling, and its cities devastated. But the American air effort was far from resting. The workload on the B-29 fleet reached its final and most unforgiving peak. And behind every mission, routine, incendiary, or unprecedented, stood Ivory Soap, holding together an air campaign that had burned through more engines, airframes, and components than any previous operation in aviation history. When the fleet could not fail. With each passing day, planners demanded more sorties. Strikes on industrial hubs. Mining operations across Japanese harbors. Reconnaissance of critical infrastructure. Escort and rescue coordination over vast distances. And the long, high-altitude missions whose names would become synonymous with the end of the war. Every bomber had to function perfectly. There was no room for mechanical uncertainty. And so, in the final days of July and the first days of August, the floating factories redoubled their efforts. Cranes creaked through humid air as they lifted engines from landing craft. Welders worked through tropical nights under makeshift awnings. Machinists rebored cylinders with the precision of surgeons, sweat dripping onto steel that was still warm from the last flight. The floating factories were no longer support units. They were the connective tissue of the entire operational structure. The most demanding sorties ever flown from Tinian. The B-29 groups tasked with the final missions required absolute reliability. Their aircraft were stripped of unnecessary equipment, fine-tuned for range, weight, and altitude stability. Every component needed to operate exactly as intended. That meant flawless supercharger performance, immaculate fuel system calibration, precise temperature regulation, structurally perfect control surfaces, stable electrical load distribution, zero tolerance for vibration in the airframe. Onshore units could replace only so much. For deep repairs, for subtle machining, for component-level refinement, crews turned to the ARU ships offshore. Electronics teams aboard the floating factories recalibrated altimeters, rewired navigation systems, and inspected gyrostabilizers using bench equipment normally found only in major depots. Engine specialists rebuilt entire induction systems from scratch. Propeller crews tuned blade pitch assemblies to exact tolerances. Structural teams fabricated reinforcement plates for wing spars subjected to extreme long-range stress. In these final days, Ivory Soap was the hidden infrastructure behind each launch. No other theater faced pressures like these. What set the Pacific apart in August 1945 were the distances. Vast, merciless distances that allowed no second chances. A mechanical failure over Japan meant ditching in waters patrolled by submarines and currents that swallowed wreckage whole. The decisions made aboard the floating factories became decisions of life and death. A machinist aboard the Major General Robert Olds wrote, "We learned to treat every component as if it were holding the weight of the mission itself." And often, it was indirect support for the defining missions. While the floating factories were not directly involved with the specially modified aircraft selected for the most consequential missions of the war, they played a critical indirect role in the broader operational landscape that made those missions possible. By sustaining the B-29 fleet with stable sortie rates, reliable long-range performance, rapid recovery from mechanical failures, and an uninterrupted supply of precision-built parts, Ivory Soap provided the strategic breathing room that allowed planners to deploy modified, mission-specific aircraft with confidence that the supporting fleet could continue its role without collapse. Every bomber that flew routine or incendiary missions in early August was maintained in part by the floating factories. Every escort, every diversionary strike, every reconnaissance flight depended on the same chain of support. In this sense, Ivory Soap underpinned the entire operational architecture of the war's final chapter. Mechanical silence before the end. On the night of August 14th, as the war edged toward conclusion, the floating factories worked one last series of shifts. Technicians cleaned tools worn down to bare metal. Engineers logged thousands of hours of maintenance performed in conditions that would have broken most civilian workshops. Machinists inspected lathes and milling machines that had run nearly non-stop for a year. Some stood on deck, looking toward the faint glow of the islands. Others wiped their hands on oil-stained rags, exhausted beyond description. They didn't know it then, but the war was hours from ending. And when the announcement finally came, many of the men aboard the ships felt something not quite like triumph, and not quite relief. Something closer to quiet disbelief. On the morning of August 15, 1945, the Pacific felt different. Not quieter at first, just strange. 4 months, the air above Tinian and Saipan had vibrated with a constant pulse of right R-3350 engines. Deep, rhythmic, unmistakable. Every hour brought new departures. Every night brought the heavy drone of returning bombers. The sound had become a calendar, a heartbeat, a measure of time. And then, suddenly, it stopped. Aboard the floating factories of Ivory Soap, the first sign came not from official orders but from the absence of familiar noise. Men looked up from their benches, from tool racks, from welding stations. No engines warming on the airfields. No flight operations. No radio chatter about incoming damage reports. Just wind. Just water brushing against steel. Just silence. A message carried over the sea. The announcement reached the ships by radio, crackling, flat, almost anticlimactic. Japan had accepted surrender terms. For a few long seconds, no one moved. A lathe continued spinning until the operator realized his hand was resting on a tool no longer needed. A welding arc flickered out as its operator lowered his mask, listening. Someone whispered, not triumphantly but in disbelief, "It's over." Yet the men did not cheer. Not immediately. They stood in place, trying to understand what a world without the next mission might feel like. The burden lifts, slowly. 4 months, every decision aboard the ships had carried weight. Every machined part was an act of responsibility. Every repaired engine was a promise made under impossible conditions. The war effort had compressed their world into a cycle of duty, exhaustion, and purpose. Now that cycle fractured, and something else took its place. Relief, confusion, gratitude, and an unfamiliar emptiness. One machinist aboard the Major General Herbert A. Darg later wrote, "When the announcement came, we were too tired to react. You don't cheer when a weight is lifted. You just finally breathe." For the first time in a year, the workshops went quiet. The Pacific without conflict. The ocean looked unchanged. Same waves. Same sky. Same humid air. But the atmosphere aboard the ships shifted entirely. Men walked the deck slowly, seeing details they hadn't noticed in months. The paint peeling on the railings, the rust creeping around the bolts, the faint scorch marks left by welding torches on the deck plates. Some cleaned their tools, almost ceremonially. Others sat on crates, staring toward the islands where they had watched hundreds of bombers rise into the night. A few climbed to the upper deck to see the horizon, calm, blue, indifferent to the fact that history had just pivoted. The first hours of peace. Without the constant pressure of mission demands, conversations changed. Men spoke quietly about home, about stateside jobs waiting for them, about fatigue they had never admitted out loud. Some slept for the first time in days, real sleep, uninterrupted by generator vibrations or incoming repair requests. Others wandered through the now silent machine shops, touching the equipment that had defined their lives. The lathe that had machined turbine shafts under enemy fire. The milling machine that had shaped replacement spar components. The welding station that had stitched countless nacelles back together. Tools that once carried the weight of survival now felt strangely ordinary. A final look at their work. In the afternoon, an officer invited the repair chiefs to walk the deck and inspect the workshops, not for readiness, but for closure. They moved slowly through the ship's interior, passing bins of spare parts neatly labeled but no longer urgently needed. Checking fuel lines that had powered welding rigs now silent. Touching engine stands that had held disassembled R-3350s glowing from heat. looking at benches covered with metal shavings from the last frantic nights of repair. Every station bore the mark of exhaustion and excellence. A floating factory built for war was finally idle. A quiet that felt earned. That evening, as the sun sank over the Pacific, the decks of the Ivory Soap ships filled with men simply standing still, watching streaks of gold reflect off the water. No bombers returning. No emergency boats. No repair schedules to meet. The war that had demanded everything from them demanded nothing now. For the first time, the sound that defined their world was gone. And in its place was a silence deeper than victory. It was peace, raw, unfamiliar, and absolute. In the weeks that followed Japan's surrender, the floating factories of Ivory Soap faced a new mission, one entirely different from anything they had trained for or ever imagined. They had to shut themselves down. War creates a rhythm. War keeps machines alive by never letting them stop. But peace demands something else: disassembly, reduction, and return. For the men who had given everything to keep aircraft flying, this transition felt uncanny. The orders arrive. Official instructions came from Army Service Forces headquarters in late August. The ARU ships would begin demobilization and deactivation procedures. No more emergency machining. No more late-night rebuilds. No more crates of damaged turbochargers arriving on deck. Instead, inventory every tool. Seal every machine shop. Pack all spare parts. Secure lathes and mills for transport. Prepare engines, compressors, and power systems for shutdown. A machinist aboard the Major General William Bryden wrote, "We spent a year learning how to work without pause. Now we had to learn how to stop." Shutting down an industrial complex at sea. The process was far more complex than simply turning off equipment. Each Liberty ship held thousands of precision tools, dozens of heavy machine tools, electrical systems tied to the ship's generators, specialized workshops built into the ship's skeletal structure. Everything had to be cataloged, removed, or secured for transport back to mainland depots. Crews used cranes to lift lathes that had not stopped spinning in months. They drained cutting fluids from tanks that had been refilled hundreds of times. Welders carefully detached ventilation ducts welded into place during the frantic early months of the war. The ships grew quieter each day. The grinding, welding, and hammering that once echoed through the hull faded into occasional metallic clinks, echoes of machines being packed away like relics from another world. Tools that had become extensions of the hand. For many technicians, the hardest part was locking up the tools. A torque wrench that had serviced 24 R3350 engines. Micrometers that had measured tolerances under the pressure of real combat. A bending brake used to shape skin panels for a bomber that had survived 30 missions. Tools worn smooth by months of constant use. Tools that had taken on meaning far beyond metal. Now each one had to be cleaned, logged, and placed into crates. No one said much during these tasks. For many, the tools were reminders of nights spent fighting exhaustion, improvising solutions, and feeling the weight of entire air crews depending on their hands. Reassignments begin. By September, men began receiving their orders. Some were to return to stateside air depots. Some were discharged immediately. A few would stay temporarily to escort the ships home. When the first groups left the floating factories, the mood was quiet, reflective. These were men who had welded, machined, and carried the war on their shoulders, only to disperse into civilian life with little fanfare. A senior mechanic wrote, "We were not heroes. We were craftsmen who did what had to be done. And when it ended, we packed our tools and went home." The ship's final voyage. The Liberty ARUs left the Marianas slowly, engines humming at lower throttle, carrying no aircraft parts, no wounded machinery, no sense of urgency. They looked almost out of place on the peaceful sea, industrial giants with nothing left to repair. On deck, crates were stacked neatly. Workshops stood quiet, locked, and marked for inspection. The cranes still pointed skyward, but they no longer lifted battered engines from landing craft. A few machinists stood near the rails during the voyage, watching the Pacific pass beneath them. Some whispered farewells to the islands where they had worked night after night. Others simply stared at the horizon, unsure of what came next. Return to a world that had moved on. When the ARU ships reached American ports in late 1945, they did so without ceremony. Newspapers did not mention them. Civilians did not greet them. Most people had never heard of Ivory Soap, and never would. The ships were inspected briefly, then reassigned, decommissioned, or sold to commercial operators. The workshops that once kept the Pacific Air War alive were dismantled, piece by piece, until nothing remained but empty steel holds. The floating factories disappeared from history almost as quickly as they had appeared. A legacy packed away in crates. The tools were shipped to depots. The spare parts were sent to scrap or storage. The technicians returned to families, factories, and schools. No medals. No parades. Just quiet return. But among the men who served aboard these ships, a truth remained. They had held the war together at its most fragile point. They had kept machines alive so that aircrews could live. And though history barely remembered them, the war would have been impossible without them. When the men of Ivory Soap finally stepped off their ships and onto American soil, the war seemed impossibly far away. The ports were quiet compared to the machine-laden decks they had lived on for months. The air smelled different. The light looked different. The world felt too soft, too still. What surprised them most was that life had continued in their absence, smoothly, indifferently. Their families had changed. Their neighborhoods had changed. Factories back home were already shifting away from wartime production. And the newspapers were filled with headlines about victory, politics, and the future, not machine shops on the Pacific. No one asked them about the lathes they'd run under battle conditions. No one knew about the metal filings swept off decks under red alert. No one could imagine a machinist working 16 hours straight to rebuild a turbocharger in the belly of a ship rolling in swells. They were home, but they were invisible. Peacetime feels too quiet. For months, they had lived inside a world where everything mattered. Every micrometer adjustment. Every precise cut. Every weld bead laid in the dark. Every component that might decide if a bomber returned. In peace, that urgency evaporated. Some returned to machine shops and manufacturing plants stateside. They found the work familiar, but the atmosphere empty. Tools were clean. Floors didn't vibrate with generators. Nobody waited anxiously behind them for the next part to save the next mission. One technician from the Major General Robert Olds recalled, "In civilian life, if a part wasn't perfect, you took your time and fixed it. In the Pacific, someone's life depended on your speed and precision. It changes how you see every cut, every measurement." For many, that intensity never fully left. The difficulty of explaining what they did. Unlike pilots or infantrymen, the men of Ivory Soap had almost nothing to show. No dramatic combat stories. No medals pinned for courage under fire. No photographs capturing what they had built inside steel hulls under impossible conditions. Their war lived in the hum of machines, the smell of cutting oil, the sparks bouncing off steel, the weight of a component held at midnight, the silent knowledge that a bomber crew depended on them. When they tried to explain it to family, the words felt inadequate. How do you describe machining a turbine wheel during a tropical storm? Or welding a cracked engine mount while anti-aircraft fire echoed across the horizon? Or watching a B-29 you repaired take off, knowing that every vibration in the airframe carried the fingerprint of your hands? So most of them said little. They carried the memories like quiet, imperfect secrets. Returning to routine. Over the next months, life settled into patterns. Returning to jobs. Attending technical schools. Marrying or returning to spouses. Raising children. Rebuilding careers paused by the war. Yet the adjustment was uneven. Some found comfort in the normalcy. Others struggled with the sudden absence of purpose. A few kept small rituals from shipboard life, cleaning tools with the same precision, folding cloths the same way, keeping drawers organized as if a mission alert might come at any moment. One machinist confessed years later, "After the war, I'd wake up and expect engines to arrive. It took time to understand no one needed me to fix anything anymore." What they took with them. Though seldom acknowledged, their experience shaped the rest of their lives. They brought home the discipline of perfect measurement, the calm under pressure learned on rolling decks, the improvisational creativity demanded by crisis, the humility of being essential yet unseen, the quiet pride of knowing what they had contributed, even if others didn't. Many became foremen, engineers, teachers of machining and welding. Some helped design post-war manufacturing lines. A few went into aviation maintenance, carrying forward the lessons learned offshore. And some never worked with machine tools again, not because they disliked the craft, but because the war had filled their minds with too many memories tied to the sound of a spinning chuck or the smell of hot metal. The unasked-for silence of peace. At night, months after returning, some still heard phantom sounds. The steady hum of generators. The metallic tap of a dial indicator. The far-off thrum of B-29 engines. The clang of tools against steel. But these were memories now, echoes of a time when their hands and machines held up the weight of a global conflict. Peace had returned. Quietly. Completely. And the men of Ivory Soap, the machinists, welders, electricians, and specialists who kept the Pacific Air War alive, blended back into the world exactly as they had worked throughout the war. Quietly, invisibly, and with dignity. When the floating factories of Ivory Soap returned to the United States in late 1945, they had already fulfilled their purpose. They had sustained the most demanding air campaign of the war. They had kept machines alive under conditions no engineer had predicted. They had proven a concept that had no precedent. But now, in a world racing toward peace, they were suddenly obsolete. The United States no longer needed mobile industrial complexes drifting across the Pacific. The war economy was collapsing in reverse, contracts ending, stockpiles shrinking, servicemen discharged, factories converting to civilian production. In the midst of this great unwinding, the ARU ships became logistical artifacts, important, but with no clear future. The first inspections, cold, technical, unsentimental. Upon docking, each ship underwent a standard post-war naval inspection. Officers walked the decks with clipboards, noting wear on the hull, corrosion from tropical climates, generator hours, condition of the cranes, stability changes due to workshop installations, and structural modifications made during wartime retrofitting. These evaluations were mechanical, procedural, and devoid of emotion. No one asked how many bombers had depended on these decks. No one measured the human cost of the work done below. To the Navy and Army service forces, the ships were simply assets to catalog and reassign. The workshops are stripped away. Decision by decision, the machine shops were dismantled. Lathes hoisted out by crane. Milling machines dismounted from reinforced foundations. Power converters disconnected. Ventilation systems removed. Welding stations broken down. Storage racks emptied and cut away. Each workshop, once alive with light and movement, was reduced to bare steel holds. The ships became what they had been before the war. Large, empty cargo vessels. A machinist who visited an ARU ship years later said, "It felt like walking into a ghost of a place I once knew." Three fates for the floating factories. Once stripped of their unique capabilities, the ships followed one of three paths. 1. Returned to the Maritime Commission. Several ARU Liberty ships were transferred back to the U.S. Maritime Commission and resumed life as cargo carriers in the booming post-war commercial market. But something had changed in them, structurally and symbolically. The scars of their wartime conversions remained. Strange cutouts in bulkheads. Reinforced deck plates. Patched steel where old mounts once held industrial-grade tools. mismatched sections of hull from late war damage repairs. They sailed again, but they carried the ghost of the workshops they once housed. 2. Sold to foreign shipping companies. Some vessels were sold to private or foreign operators under post-war surplus programs. These ships traveled to India, Greece, Norway, or South America, where they spent decades hauling grain, ore, or machinery. To most civilians who saw them, they were just old Liberty ships. None could guess that their cargo holds had once contained precision lathes humming during night raids, engine stands holding glowing hot R-3350 cylinders, teams of machinists fighting time itself. History had already begun to forget them. 3. Scrapped. A few ships, too worn or structurally compromised to justify conversion, were sent to breakers. Cut apart, melted down, converted to raw steel. The same metal that once supported the most advanced bomber of the war now returned to foundries as anonymous scrap. No plaque, no memorial, no saved artifact from the workshops. Just steel, recycled into the peacetime world. The FS ships, smaller, faster, forgotten even faster. The smaller FS-class vessels that had served as frontline repair tenders were demobilized even more quickly. Their shallow draft hulls and aging engines made them poor candidates for commercial service. Most were sold cheaply or scrapped outright. A handful ended up in island nations of the Pacific as coastal freighters, running mail, fuel, and building supplies between villages. A few served into the 1960s, unrecognizable unless you knew what to look for. Reinforced bulkheads where machine tools once vibrated. Welded seams where custom mounts had been removed. Narrow compartments that once held avionics repair benches. To their crews, they were just old cargo boats. Only the steel remembered. The quiet disappearance. By the early 1950s, the floating factories had vanished from the U.S. fleet entirely. None were preserved. None became museum ships. Their logs were archived without ceremony. Their names faded behind newer vessels. The extraordinary wartime experiment that kept a global air war alive was absorbed by the peacetime ocean, like ripples closing after a stone sinks. A historian later wrote, "Ivory Soap left no monuments. Its monuments were the aircraft that lived long enough to come home." The floating factories of Ivory Soap vanished quietly after the war, their steel recycled, their names forgotten, their workshops dissolved into the civilian economy. But their impact did not disappear. It simply shifted into doctrine, into logistics, into the DNA of how the United States fights wars. The legacy of Ivory Soap is not measured in surviving ships. It is measured in ideas. Ideas that outlived the Pacific War. Ideas that shaped the next century of American military capability. 1. Mobile industrial capacity, a concept decades ahead of its time. Before Ivory Soap, the idea of bringing full-scale industrial capability directly to the front line was considered impractical, even impossible. Yet in 1944-45, the United States installed machine shops aboard cargo ships, integrated heavy engineering into mobile fleets, maintained strategic aircraft thousands of miles from home, created hybrid crews of machinists, sailors, technicians, supported continuous operations with floating depots. This was not improvisation. It was the birth of a new logistical philosophy. If the front line moves, the factory moves with it. That concept reappeared again and again. 2. Influence on Korea and Vietnam. During the Korean War, U.S. Navy repair ships, ARLs, and mobile support squadrons borrowed heavily from Ivory Soap's framework. Rapid deployment of machine shops, forward-positioned maintenance hubs, modular shipping containers with pre-configured tools, mobile fabrication centers attached to naval groups. In Vietnam, the idea evolved further. Floating helicopter maintenance depots on converted barges, forward machine shops supporting F-100 and F-4 fighters, mobile avionics repair stations that mirrored wartime ARU designs. The DNA of Ivory Soap ran through all of it. 3. The birth of modern expeditionary logistics. What the world calls expeditionary logistics today, modular, mobile, rapid, self-contained, and capable of deploying anywhere, is a direct descendant of what those machinists built on rolling decks in 1944. Modern U.S. forces rely on mobile aircraft maintenance units, MAMUs, forward repair activities, FRAs, containerized machine shops, portable avionics benches, rapid deploy metal fabrication teams. Every one of these capabilities echoes Ivory Soap. They share a simple truth. Maintenance is not a rear area function. It is a frontline combat multiplier. This was radical in 1944. It is doctrine now. 4. Lessons that outlived the ships. The repair crews of Ivory Soap taught the armed forces several enduring principles. A precision under instability. Machining on a rolling ship proved that high-tolerance work can be performed in extreme conditions with the right preparation. A redundancy by mobility. A moving factory is harder to target, easier to reposition, and capable of supporting multiple fronts. A repair replacement. In remote theaters, fixing a component locally is faster and more reliable than waiting for supply chains stretched across oceans. A hybrid crews are force multipliers. Technicians trained in multiple disciplines outperform isolated specialists. Industry and combat must be integrated. Warfare on a global scale demands industrial capacity at the edge of the battlefield. These principles are now embedded in every major American deployment. 5. The invisible foundation of the jet age. When the U.S. entered the jet age in the late 1940s and early 1950s, the challenges of maintaining turbine engines in remote locations became immediately apparent. Once again, the military turned to lessons from Ivory Soap. Transportable machining rigs. High-strength steel fabrication on-site. Field-level repair of precision turbine blades. Mobile calibration equipment for avionics. Ship-based support for long-range aircraft. A former Air Force logistics officer once wrote, "We did not invent expeditionary maintenance in the jet age. We rediscovered what the machinists on those Liberty ships had already proven." 6. A legacy without a monument. The irony of Ivory Soap is that its influence expanded precisely as its memory faded. Few photographs survive. No ships remain. No dedicated museum tells its story. And yet, every mobile repair team, every carrier-based machine shop, every rapid deployment maintenance squadron, every expeditionary logistics element, stands on the shoulders of those workshops at sea. Their legacy is not preserved in steel. It is preserved in doctrine, training, and capability. The final truth of Ivory Soap's legacy. The men of Ivory Soap never sought recognition. They knew their work wasn't meant to be seen, it was meant to keep others alive. And the system they helped create continues to do exactly that. Their floating factories are gone. But the idea they proved has become permanent. A quiet, enduring pillar of American air and naval power. In the vastness of the Pacific, there are no markers left to show where the floating factories once worked. No monuments rest on coral shores. No plaques identify the waters where engines were hoisted from landing craft or where machinists leaned over lathes while storms hammered the hull. The ocean is wide, indifferent, and eternal. It covers everything. And yet, somewhere in that immensity, in the quiet between waves, the story of Ivory Soap still lingers, an echo of steel, sweat, and ingenuity. The war is long over. The Liberty ships are gone. The men who served aboard them grew old, lived their lives, raised families, and eventually faded from the world they helped protect. But what they built, what they proved, remains as relevant as ever. The story most never heard. While pilots became legends and battles became chapters in history books, the machinists and technicians of Ivory Soap slipped back into silence. Their work was not heroic in the traditional sense. It left no dramatic photographs, no famous episodes, no grand victories to assign to a single moment. Their battles were Precise cuts measured in thousandths of an inch. Emergency welds laid in the dark. Engine mounts rebuilt under swaying deck lamps. Turbo housings machined to perfection as dawn broke over empty seas. They fought time. They fought failure. They fought the limits of metallurgy, temperature, and fatigue. And in doing so, they kept countless air crews alive. The human dimension. Those men, welders, machinists, electricians, instrument specialists, were rarely celebrated. They didn't drop bombs or charge the beaches. But every mission, every flight, every B-29 that clawed its way into the sky depended on their hands. Many of them would say later, "We weren't heroes. We were workers." But history tells another truth. In a war defined by distance, their craftsmanship closed the gap. In a war defined by attrition, their precision defied exhaustion. In a war defined by logistics, their mobility reshaped what was possible. More than ships. The Liberty ships and FS vessels of Ivory Soap were not beautiful. They were not elegant. But they were extraordinary. Inside their steel hulls, the United States built something the world had never seen before. A moving industrial base. A factory without a city. A depot without a fixed location. A machine that fed machines. Their decks held no glory, only purpose. Their corridors were narrow, their workshops hot and loud, their nights long. But what they produced, what they sustained, altered the trajectory of the Pacific War. And that makes them beautiful in their own way. A chapter that deserves to be remembered. If you stand today on a quiet shoreline of Tinian or Saipan, you might catch glimpses of the past. Old concrete runways cracked by time. Rusting revetments swallowed by jungle. Fragments of aircraft half buried in coral sand. But offshore, there is nothing left to tell you that once, floating factories anchored there, alive with sparks, humming with machines, working through nights lit by lanterns and distant fire. And yet, their legacy endures. In the logistics doctrines used in every modern conflict. In the mobile repair units deployed globally. In the philosophy that engineering must move with the war, not behind it. And in the quiet truth that victory depends not only on heroes, but on hands, tools, and minds working in silence. The final image. Imagine one of those ships, late at night in 1945. The sea is calm. The workshops glow with a warm, industrial light. A machinist leans over a lathe, guiding steel into shape with a practiced hand. Outside, the Pacific stretches endlessly into darkness. He doesn't know if anyone will ever speak of what he does here. He only knows that tomorrow, a bomber will fly because of it. That is the essence of Ivory Soap. Not glory. Not headlines. But quiet, relentless excellence. A force built on precision, ingenuity, and the belief that even in the largest ocean on Earth, machines, and the men who fly them, deserve the chance to come home.